Good morning. My name is G. Ritvik. I am from CSE C section. My ID number is 2195180 Today we are going to see basic electrical engineering concept video. My topic is problems on equivalent capacitance of series and parallel electrical networks. How do you find the equivalent capacitance in series and parallel circuits? This is shown below. To calculate the total overall capacitance of a number of capacitors connected in this way, you add up the individual capacitance using the following formula. C equal to C total equal to C1 plus C2 plus C3 and so on. Example, to calculate the total capacitance for these three capacitors in parallel. Several capacitors can be connected together to be used in a variety of applications. Multiple connections of capacitors behave as a single equivalent capacitor. The total capacitance of these equivalent single capacitor depends both on the individual capacitors and how they are connected. Capacitors can be arranged in two simple and common types of connections known as series and parallel, for which we can easily calculate the capacitance. These two basic combinations, series and parallel, can also be used as part of more complex connections. Capacitors in parallel. When capacitors are connected across each other side by side, this is called a parallel connection. This is shown below. This is the capacitor in parallel connection. They are connected in the parallel. The capacitors are connected in the parallel. To calculate the total overall capacitance of a number of capacitors connected in this way, you add up the individual capacitance using the following formula. C total equal to C1 plus C2 plus C3 and so on. Example, to calculate the total capacitors for these three capacitors in parallel, C1 equal to 10F, C2 equal to 22F, C3 equal to 47F. The C total equal to C1 plus C2 plus C3 equal to 10F plus 22F plus 47F equal to 79F. These are the example of parallel connection. In this we can see three capacitors are connected in parallel. Example, first one, C1 equal to 10F, C2 equal to 220F, and C3 equal to 2.2F. Capacitors in series. When capacitors are connected one after each other, this is called connecting in series. This is shown below. To calculate the total overall capacitance of two capacitors connected in this way, you can use the following formula, like C total equal to C1 into C2 by C1 plus C2, and so on. This is the formula used when the capacitors are in the parallel, sorry, are in the series. Example, to calculate the total capacitance for these two capacitors in series, 10F and 22F, C1 equal to 10F and C2 equal to 22F. C total equal to C1 into C2 by C1 plus C2 equal to 10F into 22F by 10F plus 22F equal to 220F by 32F equal to 6.87F. We need to calculate the capacitors which are in the series. Is the formula C total equal to C1 into C2 by C1 plus C2, and so on. Three or more capacitors in series like C1 plus C2 and C2, C3. To calculate the total overall capacitance of three or more capacitors connected in this way, you can use the following formula, like 1 by C total equal to 1 by C1 plus 1 by C2 plus 1 by C3 plus on. Example, to calculate the total capacitance for these three capacitors in series, C1 equal to 10F and C2 equals to 10F and C3 equal to 33F. The formula is 1 by C total equal to 1 by C1 plus 1 by C2 plus 1 by C3. Here, 1 by C total equal to 1 by 10f plus 1 by 10f plus 1 by 33f equal to 0.1 plus 0.1 f plus 0.03 f equal to 0.23 f. C total equal to 1 by 0.23 f equal to 4.35 f. Here we can see capacitor combinations, like first is series and second is parallel. Third, a parallel combination in series with another capacitor. Fourth, a series combination in parallel with another capacitor. What is the equivalent capacitor if connected in series? Generally, any number of capacitors connected in series is equivalent to one capacitor whose capacitance is smaller than the smallest of the capacitance in the series combinations. Thank you.